Hi, I want to say a little bit today about importing older legacy files into ParaView VoX-FE on Windows. You'll need to, I think the best way to start really is to install MinGW in order to get access to sort of bash scripting tools like awk. And the simplest way to do that is to look up MinGW and go to the download page on there, which is this link here, which takes us to SourceForge, which is also actually where most of the ParaView files happen to be. So we'll download this setup file, and which doesn't take very long, but it just takes some time then to actually run that and install all the necessary files. It's pretty much, you've got to accept the default settings for everything. I tend to use the default for this, but I'll also install MSys as my windowing tool. It looks as if, as you can see, it's already installed on this machine, so it's not a good idea that I actually continue to do this. But if you run through this and accept most of the defaults, basically you can that should work pretty well. So if I quit out of here and I look at what this does, it does take quite a while to install everything. If you have any doubts, I'd install the development packages, but you don't really need them. You can install most of the things just from the defaults. And as I say, I tend to use this MSys tool as an actual terminal window, so that if I run msys.bat, I can do it kind of like that, and I can place a desktop shortcut on there, and so here's my desktop shortcut, and if I'm feeling really happy, I will use this tool here just to create an icon. See, something like that. Okay, so that leaves me set up then, and I've got access to tools like awk and general bash scripting kind of tools. I think another one that we use is TR to help read the files. So that is basically what you need to get going with ParaView and VoX-FE with legacy files. From there, what we need to do is download some of the bundles from SourceForge again for VoX-FE. And if you go to the VoX-FE SourceForge site, generally arrive at that summary page, but here are the files. So for Windows, currently you'd want to download this bundle for actual ParaView and VoX-FE itself. Tutorial data is also useful to work through the videos on YouTube. To get the source files, you can download one of these snapshots. But what I'd actually recommend is to go to the code section, and then I would choose trunk actually, and then click download snapshot to actually get a bundle of the code. It takes a few minutes to actually create a little zip file, but once you've done that, it just downloads it same as anything else. And in that case, you will then have a bunch of download files. I've moved them across to my own space in this source file. So I've actually got that code file here, and ParaView, and some data, and I've unzipped ParaView and VoX-FE, this bundle. You'll need 7-zip to actually extract this. As another tool that you can download from SourceForge. It's a great compression tool, so I recommend having it anyway. I've extracted these things to my own kind of bin directory, and here to actually run ParaView, you would simply launch from this exe file, and because it's all bundled together with the ParaView plugin, all you need to do then is to run tools plugin manager, and if it's not there in this list like this, we simply run load new, and because we're in that directory anyway, you should see VoX-FE, and there's your plugin file, and all being well, it should load up. I think at the moment, because I've just removed it, it didn't like that, so I'll start it again, and this time we'll start it again, and here's our plugin loaded, which means that we've now got these buttons which are specifically related to our VoX-FE plugin. From there on, basically we can load our ordinary PETSI solver files and VoX-FE files, but if we happen to have some of these legacy files from past work and previous versions of VoX-FE, and in particular what I refer to as the sort of version 0 of the solver, it's always a Linux based solver, but in that case it's particularly one. It's the one that it's not dependent on HDF libraries or anything like that. It's just a kind of system only library, executable, that uses MPI to actually solve the linear algebra finite elements problem. And if now I go to back to that source directory where I happen to save those bundle files, I have the tutorial data that I've put here, and also in the ParaView itself, I created under here, under this directory, just because that's a useful place to put things. There are some examples here I can load, but I also have some data in the statistic of this legacy file. So let me copy that across. I think this actually contains an actual version that I've already used, so haven't included this in the tutorial data set that I've just alluded to, but I may well do in future, so keep an eye out for if it's of interest. But I'm going to look at the moment at this data from a squirrel jaw, and this is what I'm referring to as my version 0 dataset. It has a script file that looks like this, which has the materials information stored at the top of the script, and then a whole stack of boundary condition information through the middle. And that works okay for sort of small to medium sized files, but if we wanted to expand the number of materials or be able to swap out the boundary condition files, it turns out to be a much better idea to put these in a separate file, which is kind of what we've done in this in our later version. So if I can manage to go back to that data set, I can close this thing. So if I look at the script that I've generated previously, I'm going to show how this tool runs to generate this file in a moment, but basically the script file that we then get is a lot more succinct. The materials file is in a separate place, and the constraints file is in a separate place, so everything's kind of nicely swapped out, and it's very easy then just to swap constraints or even swap materials without any particular hassle. You can just copy files around, and it makes things a lot more easy to handle. There are some other slight differences, and I have made another video describing what some of those differences are, but they're really pretty superficial, but it does matter. We can't interchange the files, and it turned out to be a lot easier in practice just to use awk as a tool for processing these sort of version 0 solver files. So I'll show you how that's done in a second. If I pop this down, I'll get rid of actually this existing solution here. Oops. Delete. Okay, so that's got rid of that. And the tool that we're going to use to actually do this processing for us is actually inside this zip file. So if I go to the zip file that I downloaded, if you click this download snapshot, you'll get a bundled file, which well, let's say go back to this. If I go back to where I downloaded this in my directory and source, I had this trunk zip file. It may be easier to place this somewhere else, I think, if it needs to be, but at the moment it's residing under GUI and VoX-FE tools, with all the other plugin code, and they're in legacy. So it's actually this file here that we're going to use to actually do this conversion. So if I go from here, which is quite a long-winded kind of file URL, but what I can actually do is I can copy this into my MinGW window, and the way to do it, actually, because Windows has a slightly different way of using its backslashes and forward slashes than the Unix world, the best thing to do is to do CD and then use quotes, and then click on the title bar and paste that in. So you'll see if we close those quotes and click enter, it will change this into what it feels is a more Unix friendly kind of format, but at least it saves you kind of going through and trying to figure all that out. So remembering to use quotes is really a big time saver. and then I'm going to use this where it's kind of living inside that directory. If I just copy that, and then I'll try to add this. So if I can do this kind of trick again. But we'll have to use quotes as before. If I run that that script file, it will actually execute this script as we need it in this file. But if I actually open it in Notepad, it's giving me some message here that I'm not really interested in. That's useful to just to open that file, because it gives you some description about what the output is and what the inputs are. In the other video I gave a bit more of an overview of what's actually happening here, but basically we just need to supply this script with the script file and the model file, and if the displacement file is that is alluded to in the script file is present, that will also be converted. So it should all happen fairly automatically after this point. It's just all that we needed to do was to open this window to get things moving. And so if I actually run that then on the data that's in this directory, which if I type ls, we will see that. So this is our data that we're in. This is the work that we want it to do. So if I call that again, that plugin script, but now I supply these two arguments, so that be script, and using tab I autocomplete. That's another very handy feature of the terminal windows, and that's all I really need to do to supply that data to the script. If I now hit enter, it runs through the file. It's found the displacement file, which is actually, if I think it was still open in here, wasn't it? It's actually, so this was the model file that's referred to in the script file anyway. I actually supply that as a separate argument just in case it is somewhere else, because sometimes it is. People do like to store their model files in different places. But if I scroll down to the end of that file, you'll see that the displacement file is referred to here, and this was found inside the same directory because it's actually here, and so that was processed too. And the great thing is it's now created our ParaView VoX-FE file again. It's created the files we need. It's also left some other files that we don't quite need. This one here, it looks like oh yeah, it's still running. Okay, so that's finished, and these are actually the files that we need. It's actually created the output in a file called displacement_x some number, because I don't know if you noticed, but there was an option to actually scale up the displacements, or even scale down the displacements if you actually require that, because there's some kind of modulus change that you want to experiment with. But normally you wouldn't need that, and I didn't supply anything, so it used a default value of 1. So we've got our displacements, we've now got our script and model files. The thing that we then need to do, of course, is to just load those into our ParaView. So I can make another copy of that address and paste it in here, and didn't do that. paste it in here. Didn't like that, so I'm just going to delete it, try it again. In here. Here. Right, okay, we've now made our way to this script file in the correct place, and if I open that in here, I always tend to leave auto apply off. There's a button up here which is auto apply, which is very useful when you're actually getting down to your later stages of kind of analyzing, using slicing and clipping and that kind of thing. But at the moment, when you're trying to do important things like big things like import files, it's better to leave that off, and that allows you then to go through these options as you're importing the files. As it happens in this case, it's not necessary to actually change anything, but if I hit apply, it will take a few minutes to load up, so you have to be patient. And there we are, that's great, looks okay. And if we next thing we would very likely want to do is to take that displacement data and convert that into strains. So if we go to the strain button, there's our displacement file, and as I mentioned before, we don't I haven't got the auto apply on here, and that is the correct thing in this case, because this is not PETSI solver output. This is from this sort of version 0, albeit slightly converted into the but it's from a solver that we call ParaView. So you have to change that to that option. Click apply again. Again, it takes a little while to read through all that displacement data and recompute the strains. So again, should be there in a moment. All being well. Yeah, oh, it's taking some time to compute. There we are. Don't really want that, but now we've got the strain information. So if I move to that, because this is actually selected, actually what we get are some data values in here. No, not that one. Oh, information, here we go. Some data values in here which will tell us roughly what these kind of values are. I'm going to have to move this across a little bit. You can see that it's actually overlaid these strains on the page, but it's very useful to have these kind of limits showing. You can see that mostly the model is blue here, so it means we want to adjust that upper end to make it clip a little bit sooner. So color map editor, if we show this editor, and I raise this up a little bit on the screen, I don't know quite why I've got this thing here, but then if I set this limit, so I bring down the top end of this limit to say 0.1, might get something of a more interesting picture. Okay, that's more or less all I wanted to say in this tutorial. Thank you very much for listening. Okay, bye.